start by, okay, so here's your, this one chapter, motors and appliances. A couple of things, guys, I want to say about motors and appliances. I didn't synchronize myself. It's always nice to synchronize yourself. Oops. Okay, miss that one. This one, not this one. Okay, so here's what this, hopefully this chapter will focus on. A couple of things, guys. Appliances, utilization equipment. What is an appliances? What is a utilization equipment? A fixture is a utilization equipment. A machine is utilization equipment. Um, Electrical appliances, circuits. I remember last class, guys, we took an appliance and we sized the disconnect, the overcomputation device, the feeders, the branch circuits. Disconnects for appliances. We'll talk a little bit about disconnects for appliances. Very big deal when it comes to appliances. So basically, appliances and motors, appliances and motors. Couple of other things. Identify the grounding for appliances. All appliances, for the most part, must be grounded, meaning you have to provide an equipment grounding conductor for the appliances that can be coming from the receptacle or it can be hardwired. And that thing, this one, you guys have done it. The branch circuit rating, the conductor size, the overconduction device for the appliances and motors. I know last project we did a lot of calculation for these. You guys did a lot of application for me, so that will be a review. These are new. I don't know how many of you guys know type 2 and type 1 protection. Type 1 and type 2 protection. Anybody knows what type 1 and type 2 protection when it comes to equipment and machines? Type 1 and type 2, that's new material. Not really rocket science, but new concept. How do you protect the machine? Both of them meet the code. You have to meet the code. So which one is better and why and what do they mean? So these are kind of the hopefully the things that we can do. Here's how the NEC gets define appliances, utilization equipment, something that utilize the power in standardized sizes, like washing machine and so forth, or types that's installed or connected as a unit to perform a specific function. So this, when we talked about these one, that will be all the cooking machines, anything that cooking machine, washing machines, garbage disposal, garage door openers, all these things will be manufactured in a standardized shapes and bought and sold and installed to the electrical system. The article that talks about these boys, article is 422, if you guys remember that, and we have a couple of rules we'll go over. The manufacturers, when you guys have, now we're in a commercial, so in a commercial, you're going to have a dough mixer. There's a dough mixer in this commercial. That's an appliance, sold and bought, a dough mixer, right? This dough mixer, 99.9%, 99.9%, the manufacturer will be putting you the maximum size and protection device, the overprotection device, almost always right on it. Otherwise, we're going to be using 240.4 for appliances not marked. Then you're going to use 240.4 and 422. If you guys remember, where the 13, remember that 13.3 amps or less, 20 amps more than that, we use 1.5 the size of a protection device. But almost always the appliances, guys, that you have in a commercial industrial application, it's going to have what? The nameplate on it that says what's the overprotection device, what's the conductor size, what's the amp, what's the voltage, and you have to provide a disconnect for it. Okay? So that's really in the most part of it. The other one, appliances grounding. All appliances must be grounded, period. So you have to pull an equipment grounding conductor based on what? Jeff, based on overprotection device. No rocket science. Appliances disconnect. You have to provide a disconnect for all the appliances that you have. That disconnect, there are multiple shapes of disconnect. The disconnect, guys, here's a disconnect right here. This guy qualifies as a disconnect. The plug can qualify as a disconnect. A snap switch for small appliances is a disconnect. Bigger appliances, you're going to have an EMA-rated disconnect switch right on the wall where you can lock it and tag it. This is another application for disconnect. So that's basically what this is telling you. So if we have permanently appliances, you can use a plug, you can use a disconnect. If you have a motor, you have to apply the rules of a motor for the appliances, which means if you have major motors in them, the disconnect have to be rated to handle the horsepower rated disconnects. We'll talk about disconnects and the site and so forth. Appliances means some appliances, guys, heaters and so forth, they will have a disconnect part of the appliance, right on the appliance, and you flip it and it says off. That qualify on the appliance as a disconnect. Like heaters, notoriously famous of them, you have a switch that qualify as a disconnect. Cord and plug also is a disconnect. So when it comes to appliances, what I want to emphasize, when it comes to appliances, you need an overcurrent protection device tied to a branch circuit that feed the appliances, and you need some type of disconnect to disconnect these appliances. That could be snap switch, that could be the plug itself, that could be a big NEMA on the wall disconnect, that could be the circuit breaker if it's within sight, like we did with the water heater, if you guys remember. So these are the things to focus on when it comes. When you guys were laying out your mechanical equipment, do you remember what we were doing? When you're reading through a spec, it always emphasizes one thing, disconnect or starter with disconnect. Do you hear the word disconnect all the time? For safety, all machines, all equipment must have some type of a disconnect to disconnect them, isolate them, to work on them safely. So that's a couple of things about disconnects. Okay. Moving into a motors. Now for you guys will be motors like air handling unit, chillers, and so forth. So there's a couple of things here about motor failures that probably for you guys would be, since we don't work on motors, I don't know how much of a big deal would that be for us, but let me just go over this one. So disconnect, we talked about the disconnect. We'll show you a couple of disconnects in a second here. Okay, basic of motor circuits. Motor circuit, guys, I teach motors for electricians, not for designers. When you guys, you're not going to be involved in it. The only time you're going to be involved in motor failure for existing motors, if you're a project manager. So Darren, if you are hired as a project manager for a plant, part of you have to put the plant, all the equipment on a schedule, annual maintenance schedule, so you can maintain these equipment before it fails. Then there is tons of information about how do you maintain equipment that has motors. What could go wrong in a motor? A machine that has motors. So typically for designers, when we design them, it's really nice to know, but we don't get involved in the bearings and sizing the bearings and so forth. So this is FYI probably. Motor failures. Why do we care about motor failures? You don't have heat if the air handling unit stops working. Do you have heat and cooling in your building? No. So here's what a couple of things that contribute to it. Abuse, lack of oil, bad bearings is a very notoriously famous for making your motor fails. Who cares as a designer? Really nobody. As a project manager in a plant, if you're a project manager in a plant, or electrician troubleshooting it, that's a big deal. So you walk into a motor, the motor is not working. How about, have we oiled that thing for the last 15 years? So all these are big deal. And also consult Electrical Appliances Service Association. There's a lot of information about the appliances and the motors, guys, that comes from the manufacturers that you have to follow. How often do you have to change the oil? How often do you have to oil them? How often do you have to build the V-build, torque them, align the V-build? So tons of information. So I'm not going to skip on the motor failure, just FYI, disconnect. When we have motors or any machine driven by a motor, the code requires you to have a disconnect. The disconnect has to be within sight of the motors or the machine, and the machine and the controller. You're going to see in a second. Disconnect must be horsepower rated. This is the most important thing about the motor. When we size disconnect, we didn't do it, guys, with you this quarter. We will be doing it next project. We will be sizing disconnect. We size them based on amp, and you say 60 amp disconnect. Later on in next project, in the industrial project, we're gonna go. You guys are gonna go and size it also based on horsepower. So if somebody is to accidentally shut this, flip this one down while the motor is running, it's not gonna explode in your face. That's why they rate them based on horsepower. So it means you can interrupt the load. You can interrupt the load with them. Not a big deal. So it becomes like it's 60 amp, 480, 277 at say 15 horsepower. So that becomes the rating given horsepower, actual horsepower rating for your disconnect. We'll look at a couple of pictures in a second. This is the most important things, guys, for us as a designers and for safety. Disconnect rule number one, there's a couple of rules inside of the equipment and must be inside of the motor, location, and driven machine. We'll look at it in a second. Start stop does not qualify as obviously as a disconnect. No consideration to be the code. So start stop buttons that you see here, they're not disconnects. I'll show you guys in a second. I'm going to flip over that one. I'll show you the disconnect. So if you have a disconnect, here's my disconnect, guys. Here's my controller, and here's my motor, and here's my machine. The disconnect has to be within sight of the controller, within sight of the motor, and within sight of the machine the motor is driving. Does that make sense? Otherwise, what do you need to do? You have to have a disconnect for the controller, the motor, and the machine. Some exception, I have a nice picture to show you about the exception. Air conditioning also need a disconnect, guys, within sight of the equipment. Exhaust fans, single pole snap switches for fraction horsepower are approved as a controller and as a disconnect, like bathroom fan is a good example of that one. Only fraction horsepower motor. We can't do that one on a 50 horsepower. Here's a good example. Here's a fan, and you're using this switch. This switch is actually used both as a controller and as a disconnect. Can I have thumbs up, Chad? No problem. We've done that in the residential. Okay, I'm going to fly through these because of one reason. We have done them. We will do them again, guys. Basic of motor control. Motor branch circuits. Does that ring a bell when we take 125% and multiply it by the full load current from the NEC code book? Everybody understand that one? We've done it multiple times. Color code for motor branch circuits. Motor branch circuit, guys, are like any other branch circuit. When we color code them, we use any color except the green and the gray and green, gray, and white. Because these are dedicated green grounding. You have to use it with the grounding only, not for the phases. And white and gray are used for the neutral. Any other color than that, so you can use red, brown, yellow, any other color, like any other circuit, like exactly like any other circuit. In your book, guys, they have a list of colors that they use. So they're using black and white for single phase. They're using black, red, and blue for three phase, black, red, blue. Typical. So they like any other branch circuit, Okay, motor overload protection circuit from, we have, as we guys know, we have to protect the motor from overload. And I remember, Jerry, do you guys remember when he showed you the overload protection for the motors that we use? We have the heaters and we have the electronics. The idea is if you are to overload the motor, it will open to protect the windings. I have a nice picture I'll show you in a second. Must be common form of motor overload protection. We have overload relays. These are the electronics or the heaters. The type of overload, you have electronics on the set. I know Jerry, when he comes, he showed you all these relays that they use. We have manual, some with manual or auto reset relays. So typically two types: the heaters, the ones that heat to disengage the circuit, and the electronic ones, which have a relay. The electronic ones, you can manually or automatically reset them. These relays. Motor have different classes of insulation. For motors, guys, they have classes of insulation. Higher insulation makes insulation class for electrical motors. We have A105 to D180. These insulation, Darren, are the windings, the magnetic winding insulation inside the guts of a motor. If it's rated for higher temperature, meaning you can abuse the motor a little bit more, and it wouldn't smoke on you. So you'll see a couple of things. Manufacturers select motor based on their use. So if you have a motor that's going to be abused more, you need insulation that rated for a higher temperature, 180 degrees Celsius. Meaning it will reach 180 degrees Celsius before the smoke starts coming out of this motor. Right? But versus if you use 105, 105, you can't abuse it that much. At 105, smoke starts coming out of it versus at 180. So anyway, these are good examples. Service factor. There's a term that called service factor that goes from 1.15 all the way to 1.25. This is how we talked about this one, guys. This is how much you can overload you can throw on a motor. For example, if your motor is 100 horsepower, you can throw 25% extra on that motor load. So overload depends upon the service factor. Obtaining the multiplied by the horse will give you how much overload you can put on this motor. Does that make sense? The service factor. So a service factor 1, 100 horsepower is 100 horsepower. Service factor 15, 100 horsepower is actually can deliver 115. Who cares when you size the overload? Your size of overload can be bigger to accommodate for the increase of load in that particular motor. Okay, how does current flow and the winding of a motor? Single phase motors. This is just a couple of things to justify the overload, guys. If you have a single phase motor, you have to have an overload in phase. If you have a 3-phase motor, you have to have an overload in every phase, right? I'll show you a couple of pictures. We'll talk about this one. So overload are required. Oops, let's go back. Overload are required in every motor, in every hot. Let's look at this. There is a concept in the 3-phase system, guys, called single phasing. Anybody knows what a single phasing is? What's single phasing? You have 3-phase. What the term that they use for single phasing? Thank you. You lose 1 phase or 2. That's single phasing. So you have 3-phase coming to your building, and the utility transformer blew up, fuse, and now you only 2 phases. Now everything in your building is single phasing. Single phasing is dangerous on 3-phase loads. So single phase means 1 phase is open, 1 or more. Can be caused by, here's the cause for single phasing. How about power line down? 3-phase power line, 1 of them went down, 2 are up, so you have your single phasing. Utility company transformer fuse blew up or cutouts, open connection, bad termination, open splices, broken conductors, burned contactors. So long story short, guys, these could be the situation where you find yourself. This is a really nice example, if I can have your attention, guys, on an overload. So look at this. This is the transmission line coming from Excel, and there's a storm, and it knocks down the phase A. Here's phase A, phase B, phase C. Cool? I knocked down only phase A. Now phase B and C is still giving juice. So look what happened. I don't know if you guys can see that. When you lose phase A, the current on phase A becomes 0. This motor was rated for 10 amps. It's a 10 amp motor, okay? So the motor is running. When you lose phase A, the motor continues to run. But in order to give you the same horsepower, it compensates the loss of phase A by the other 2 phases. So look at that. We went from 10 amps on each phase into 17.2, right? 17.3. So we went to 17.3 on each phase. Anybody knows why it jumps? The current jumps because I only have current now in 2 phases. Okay, now what happened? The motor continues to run. Now look at this. Now the coil here is rated for 10 amps. What happened when you put 17.3 amps in it? Now instantly start heating. You have a coil rated for 10 amps and you put 17.3 amps in it. You start heating up, and after a while, what happened? Smoke starts coming out of it, and it burns. Except when you set your overload, can you guys see the overload here? The overload is set at 12.5. So before this starts smoking, what do you think the overload is going to do? Open. That's one of the most important advantages of overload in a 3-phase system. The fuses, it wouldn't even wake up. The fuses are rated. So in this case, probably you're going to have a 20 amp fuse. Yep, 20 amp fuse. Do you think a 20 amp fuse will see 17.3? No, wouldn't wake up. Can you guys see the importance of overload protection? Single phasing. So that's a good example of single phasing overload protection. Okay, single. Now another thing, guys, that could happen for single phasing. If you have another machine, this is really interesting. If you have another motor here, and this motor is all connected from two phases. So this supposed so this is 10 amp and this is a 2 amp motor, right? If you single phase, here's what happened. If you guys, and this is also another three phase coming to it, three phase. If you have a single phase condition, the second motor, the smaller motors will continue to run, and the bigger motor will generate equivalent to the loss of the phase. I don't want to be even deeper on that one. That's confusing for the maintenance electrician and engineers, guys. You go walk in and you measure the phase and you look what looks like there's a voltage in it, but that voltage is generated by this motor into this motor, even though we lost phase A, but we still have voltage and running other motors. So long story short, if you have single phase condition, your three-phase motor continue to run. If it's half loaded, it will continue to run, and it will actually generate the phase that's lost for other smaller motors to start and run. So just be aware of that one. I know you guys are not maintenance guys, so that's what strange things happen. Unbalancing the voltage also can cause your equipment to burn. Unbalancing your voltage can cause your equipment to burn. So if you have a NEMA, I think NEMA goes for 5 to 10% plus or minus voltage drop. So if you have an unbalance in the voltage, guys, will also affect your motors. So motors will burn. Unbalance, it will create, why? Because it will create an unbalance in the current. And it will, I have a table, it will affect the operation of your motors. It will affect the operation of your motors. We'll look at the cable in a second here. When you have short circuit protection, guys, you have to have an overcome protection device based on this table, which we sized many times, you and I. And that could be a dual element time delay fuse, an inverse type circuit breaker, instantaneous strip, or non-time delay fuse, size to allow the motor to start and run, And we size a few of these. We know when you do the calculation, guys, on these tables, when the amp does not match a standard, we go up, right? We've done that a few times. There's a couple of tables I'm gonna tell you. There's another concept for motors, guys, locked motor current. Locked motor current is the highest amount of current that you could draw from the motor at the start, or if the rotor stalls. There's a code, multiple code letters that we use to size these. The higher the letter, the more the locked rotor current, and the worse the situation could be. Here's a table that we have that we use, and I know you guys used it, and we will be using it. It will give you a letter code for the locked rotor current. So based on that letter, you calculate the inrush or the locked rotor current. Who cares? The question is, who cares? This will decide if your fuse is going to blow up when you put it there. If your equipment is going to have the torque of your equipment, and a bunch of other things. There's also NEMA letters for motors. I'll show you a couple of things in the diagrams here. It's really nice in the diagram that we have. Moving on. Okay, here's where I want you guys to wake up. There are two types of coordination and protection. Type 1, if you have an overcome protection device, type 1, fuse type 1, it will interrupt the circuit. So if I have a fuse protection right here on this controller type 1, after the short, and I have short circuit right here, if it's type 1 fuse rated, then it will not explode and kill me as an electrician, but it will damage the controller. You might have to come back and change the controller. Type 2, you will put a fuse here that will protect the equipment from exploding in your face and killing you, and at the same time, your equipment will be reusable after the short circuit. Can I have thumbs up, Chad? That's it. That's the type 1 and type 2 protection. So if you have, take this, if you have a very expensive control, which type would you think you're going to do? Type 2. If you have a cheap piece of controller that you really don't care, which type you could do? Type 1, right? So we have an expensive controller type 2. How do they make type 2 and type 1 guys? By putting a fuse size appropriately. Size a fuse appropriately. Any question about type 1 and type 2? So type 1, it lives the equipment will not explode, safe, but you might have to go replace everything. Type 2, it's safe, doesn't explode, and it keeps the equipment for the most part intact. So that's mostly for control equipment. Okay, fuse disconnect overload. Okay, equipment installation. So 15 branch circuit. This is just the equipment and lighting panel. We talked about this one, guys. If you put equipment on a circuit that feeds other light and receptacle, you guys remember that number? 50%. If you have equipment, plugged in equipment on a circuit that feed lights or receptacle, that equipment have to be rated 50% of the rating of the circuit. If it's dedicated circuit, it's rated for what? 80%. So remember that one. So why in a commercial industrial, guys, that's why we always give a dedicated circuit. You have a dedicated circuit plugged in or hardwired, individual branch circuit, you can load it up to 80%. Who cares? I have a 20 amp dedicated circuit to a machine here, 3-phase. That machine I can feed 16 amps on that. That's 80%. So if my machine is 16 amps or less, I'm covered. I can't feed 20 amps. Right? It has to be 80% of the rating. Can I have thumbs up, Chad? That's how we size everything with me, guys. When you were multiplying by 1.25, that's exactly what you were taking into consideration, the 80%. Okay. This one, guys, is going into the project that we have, not the project in the book. And they have a commercial oven there, has a nameplate on it, and they're using number 6 to feed the commercial, and the full load amp is this amount, so they're sizing. That's how we came up with number 6. We have a disconnect means without overcurrent protection device to protect it. So this is just specific load in the project that they're feeding, an oven. If you have conductor supplying different motors, guys, on a one branch circuit, not a good idea. You have a branch circuit that feeds multiple motors. You take the largest motor, increase it 25%, full load of all the others. Does that sound familiar to you guys? I hope so. We're going to do it again in the next project, do a couple of examples, commercial, but 25% of the largest plus full load current of all the others. It's not a good idea to put multiple motors in a commercial building in one branch circuit. That's why, Aaron, when you were doing yesterday with Revit, what were you guys doing? You were sizing things one branch circuit for every motor. A motor, every machine or motor will have its own branch circuit. If you have a feeder that feeds multiple motors, which is common, then you take the largest motor, multiply it by 1.25 plus the full load current of all the other motors. And when we size the overcurrent protection device, we take the largest overcurrent protection device of the system plus the full load current of everything else, and we go down. Good. Magnetic motor starters. Yep. MCC, motor control center. Yeah. Yes. If you have a motor control center, or if you have a mechanical panel, the same. Any panel. So if I have a panel right here, and out of these panels, right? All these, this is my panel, and out of these panels, there are multiple motors fed from it, right? Don't you guys think this is a feeder, right? Feeding a panel. This is my mechanical panel, or this could be also motor control center. The only thing in a motor control center, they add a controller here. They add a controller. Either way, when you size that feeder, coming to it, an overcurrent protection device, that's how you size it. The largest motor multiplied by 1.25 plus the full load current of all the others. And the overcurrent protection device, suppose this was 100 amp, then this had to be 100 amp plus all the other motors. And then if it's not a standard, you go down. We did the calculation for this, and we'll continue to do it, guys. when we do the calc, we'll continue to do it too. Make sense? No? Okay, so that's my calculation. Appliances disconnect. This is just a couple of sets of articles, guys, that you have to have a disconnect for your appliances. I want to remind you guys, you can have a cordon plug for the appliances as disconnect, permanent connection appliances. You can have a disconnect in the wall. Disconnect means rating. You have to have an amp rating and a horsepower rating for your disconnect. It has to be within sight of the equipment. So these are just a bunch of articles that talks about the disconnect for equipment. Grounding. Every single equipment must be grounded, period, done. So you have to pull an equipment grounding conductor with every equipment. And these are all the articles that tells you, if you have a plug, if you have a cord like this, a cord, and you plug your machine from the cord, the grounding conductor is going to be inside the cord, right? And taking your ground from the plug. Okay, so that's grounding. Overcome protection device for appliances, talked about that one. Baker can have types of equipment, manufacturer, furnish. This is a couple of things about the equipment that we have in that particular book, and they have to supply almost everything about that particular equipment. We have a mixer in the bakery. We have a mixer and a dual divider. There are three appliances, and they're doing the calculation for them exactly like any other motor. We have an oven, 60 amp. They size the calculation based on the information provided by the manufacturer. You guys have done this with me. You are doing it right now with all the mechanical equipment list that I gave you, that you're sizing the branch circuits for it. You're sizing the branch circuits for it. So that's what I will talk about this one in a second. What I want to emphasize, guys, is a couple of pictures really here. The pictures are okay. Here's I want you guys to pay attention to this one. Here's a machine driven by a motor, a controller, and a disconnect. So the disconnect, if it has to be one disconnect, that disconnect has to be within sight of the controller. The disconnect has to be within sight of the controller, the motor, and the overload, and the machine. Can I have thumbs up about this? Cool. Otherwise, if that's not the case, then you have to have they have to be within sight of all these three. If you can't maintain this, then you have to create. Look at this. You have to have, if you can't, then you have to have a disconnect for the controller and a disconnect for the two. So here's one disconnect for these two together. That will be this, and one disconnect for the controller. That will be that. Cool. So the rule is all these need a disconnect. Okay. Now, only this is my favorite because they use it a lot in industrial application. This is really interesting. Now, you can have a disconnect not within the sight of a motor or the controller driven machines, only if it can be locked in open position and only under these circumstances. Exception. If it's impractical to put it, or if it's dangerous. Where's the other one? Impractical, or written safety procedures, or increased hazard. Impractical or increased hazard, or in industrial establishment where written safety procedures are followed and qualified people are maintaining it. So you get into a factory, you might have your disconnect somewhere else for the machine, the controller, and the motor. Why? Because those guys are supposedly smart people. They're maintaining the equipment. They know how to lock it and tag it. Can I have thumbs up, Chad? We know how to do that? Okay, so can I get you guys to understand that this situation is the exception, not the rule? The exception, not the rule. So the rule is you have to put the disconnect within sight of the controller, the motor, and the machine that's driven by it. Thumbs up, Chad? Cool. That's what I want to bring home. We talked about controller, guys. The controller can be as easy as a disconnect for a fraction horsepower motor. This is a couple of overload sizing. Do you guys remember when Jerry was here? This is how you size your overload. For example, motor full load amps. If your motor full load amps, let me just go a bigger motor. Motor full load amps of motor full load amps current thermal unit protector. So let's just say 1 unit or 3 units. It depends upon three phase or single phase. Let's say three phase, and I have my motor. Full load current is between this and this. My protector is going to be B4.15, the type of the protector. Who cares? When you guys size these, you can go and use these tables. I know Cutler Hammer has tons of them. Okay, here's your nice, beautiful motor. Your nice, beautiful motor that's running at 10 amps. Can you guys see the 10 amps out of this motor? And it's shiny, beautiful, no burning in it, right? Everybody can see it's a 10 amp motor. It's pulling 10 amps. The overload is rated for 12.5, and the fuses are 17.5. Special fuses rated for 17.5. Cool? Now that's how it should be. Now what happened? Look at this. What happened here? The same motor, we have an overload condition. Can you guys see what happened to the motor here? What happened to it? Burn, completely burn. So that beautiful 10 horsepower motor is pulling 15 amps, 15 amps, 15 amps, right? And it's supposed to only rate it for 10. And the overload protection is sized wrong. They're sizing it wrong. Instead of 12 and a half, your overload protection is sized for 15. So do you think, and the fuse is 17, do you guys think that the fuse or the overload protection will see a 15 amp overload? No. So what's going to happen to the motor? You're looking at exactly what's going to happen to your motor right in here, charted. If this is a big motor, here's $500. Bigger motor could be thousands of dollars. Can I emphasize, guys, the importance of the overload? So I thought that will bring it home to you, and how to size it appropriately. Were you?
Where did they get that 17.5 from for the overload?
Somebody sized it wrong.
Wrong. Okay.
Yeah, they were sized wrong. Okay, take this. This is a 10 horsepower motor, the same 10 amp motor. When you size it 1.25%, that will get you an overload 12 and a half. That's proper, right? Now look what happened. If you have an open phase, single phase condition. Can you guys see the single phase condition? Everybody can see that? Single phase condition. Now this phase is out of service. It has 0 amps. The motors are so stupid that they start pulling current from the other two phases. Can you guys see that? They start pulling current from the other two phases. So we have 17.3. Now, here's how it looks like if you have single phases. Can you guys see certain phases are burned, other are not? So if you have a single phase condition, your overload doesn't trip. This is what your motor is going to happen to your motor. Now, I want somebody to answer this for me. I have 17 here, and my overload is rated for 12 and a half. Do you think I'm protected? My overload is going to trip at 12 and a half, and I'm pulling 17.3. Yes, it will trip, right? If this is rated for 12 and a half, this motor is protected. So it will trip before you see this condition. Now, here's where you can tamper with that. If you put this in a 20 amp, and you add this is 20 amp, all these are 20 amp. Now, do you think your motor is fully protected? No. Now, do you guys understand why? Do you guys understand why the overcompression device of motors is very important? Because you don't want to be looking at phases, at the multiple phases here burn. Phases burn. Okay. Any comments? Any questions about that?
So they use 1.75 for the fuse size then?
For the fuse size, yeah, they're using 1.75 from table 430.52. Absolutely. Absolutely. Okay, so open. This is a delta motor. The same thing could happen to a delta motor, guys. The same thing that could happen to a delta motor. They're using a delta motor. If you open the delta, if you open a phase, you're single phasing. Here's how your current, here's your overload. Your motor is protected at this amp. So are we protected here from single phasing? Are we protected from single phasing? Yes, because the overload is bigger than the current that the conductors are carrying. So we're protected from single phasing. Single phase protection. Okay, here's another scenario I would like you guys to look at. Now, single phasing on the primary. If you have a transformer, look at this one. This one, we lost the phase on the primary of the transformer. Look what happened on the secondary. On the secondary, because it will generate the phase I have 11.5, 11.5, and 23 amps, 23 amps, 23 amps. Am I protected here? If this pull 23 amps, do you think this fuse will trip? It will trip, so I'm protected, right? So that's where another, and also, if you don't put overload, if you don't put an overload here, you typically have to put an overload here, but if, in this case, you are protected, but if your overload is here 2.5, overload, and this one will, the overload will trip. The overload will trip. If you don't put an overload, this fuse will not trip fast enough to protect your motors. Guys, overload can trip. Most overload trip within 20 seconds, 10 seconds, 20 and 30 seconds. So this guy, if it sees 23, it will trip within 10 seconds, done. Or 20, typically a lot of them are 20 seconds. Now this fuse, it might take this fuse a minute to trip. So what happened if this overload does not trip within 20 seconds and the fuse trip within a minute? What's going to happen to the windings here? Smoke. Smoke. Smoke will be coming out of it. Okay, here's where a strange thing happened. I like these because if you have single phase in, if you lost a phase, this big fat boy will continue to run, act as a generator, and generate phase, the lost phase, and even start motors. You guys will appreciate this one if you're doing a project management and all this good stuff. So be aware, if you have in a manufacturing floor, you lose a phase, you might not be able to know that you lost a phase. The equipment, if it's slightly loaded, it continues to run and heat up. And the smaller motors, because this acts as a generator, generate phase, this smaller motor will start to run normally, even though you lost the phase and your equipment start heating up. So if they're not properly protected, your equipment will burn. Okay, this is a curve of a start current. When you guys start, oops, not this, when you start an equipment, the current is going to be so high and it is going to go all the way down. This energy, do you guys remember what Jerry was talking about, this energy that they're trying to reduce the other day? This is very similar. You start your motor because of the air rush is so high, the current will go high. After 10 seconds, it tampered goes down. So this is a 10 amp at, what is it, current 10 amps. So let's just say this is 25, let's just say this is 4 amp full load. So it's going to give you close to 24 amps when you start the motor. Typically, 6 times 4 is 24. 6 times or 600%. Okay, this is a couple of an example of a machine that they have in this project, guys, and where you're getting the ground. Really, what I like about this is they're getting all the I don't know if you can see the overload protection here for the motor, and everything is plugged in. So you're getting your 3-phase from 15-20 plug. This is a 20 amp plug, and you're getting all these 3-phase and the ground directly from the plug. I think one of the machines that they're using in the manufacturer in the floor. Okay, appliances. We talked about this one, guys. Here's a typical application of appliance. You have to have a disconnect conductor first. You have to have a disconnect, overload protection, and the conductor again. And you have to have an right in here. You will have some type of an overcurrent overload protection inside the appliances. And we sized these, guys, as you guys remember. We talked about the conductor 1.25, if you remember that one. Disconnect 1.15. We talked about the overcurrent protection device, either 1.5. All these are multiplier, right? And the overload 1.15 or whatever the manufacturers talk about it for your appliances. This is a couple of pictures, guys, about the motor. Look at these charted motors because of applications. I'm going to move through them. Yeah, this is my favorite. Sometimes what they do, guys, for supplemental protection for motors, they add a fuse to protect the plugged-in motor for extra protection. They size. So if you have in a manufacturing floor or in a factory, you have a machine, you plug it in. You don't want to depend on the circuit breaker to protect it because it's expensive. What they do is they have a little box like this where you plug it in here, but there's also a fuse specifically sized to protect this machine that's plugged in here.
Is that current? Is that like so we actually still use S-type fuses or something like that?
Yes.
Or is that an old picture?
No, you still can use S-type fuses for this. Absolutely.
I didn't think anybody did.
Supplemental, but this is a supplemental, non-dwelling, supplemental overcurrent protection. Supplemental. Supplemental. I emphasize the word supplemental for better protection. Okay, here's a couple of equipment used in this place, guys, and you probably have seen them. Electrical value for water here. This is a calculation for how did they calculate the branch circuits for a motor. I'm going to highlight one of them and then off. In the women's toilet, we have a kVA of this amount. Here's how the amps multiplied by 1.25. Here's the overconduction device. Here's a conductor, and it's cord and plug connected. Guys, these are taking different type of branch circuit and sizing up. Exactly like we did. If it's a motor 1.25, blah, blah, blah. So sizing different type of, for this, it's going to be heaters. If I may emphasize this one, Zach, my friend, when you size the overload, here's your multiplier, and we use this one. If your service factor is not less than 115, 125, temperature not over 40, 125, all others are 115. Please, this is directly from the code, nothing new. Here's the insulation type of a motors that you can buy. The best one is D because it can handle up to 180 degree temperature, right? So that's good news. Here's another really nice table that guys talk about variation in table. So if you have 110% over voltage, look what happened to the full load current. Decreases, starting current increases, temperature rise goes up, and full speed increase slightly. So within 10% plus or minus is what motors like to do. You go higher than that or lower than that, your motor will work inefficiently and they will prematurely die on you. Can I have thumbs up, Chad? That's all. That's all what you need to do. Percentage of voltage unbalance. Look what happened to your derate your motor. If you have a 5% unbalanced voltage, your motor have to be derated based on 75%. So that's why you want your voltage to be balanced. Who cares? Here's what a voltage balance, guys. Suppose I have a 485 and a 490 and a 470. Voltage, voltage, voltage. The system is 480. Can you guys look at these? Is this a balanced voltage system face to face? No. Okay, how do you find the unbalance? Can you do that one? Can somebody do that one for me? Can you guys add him up, please? Add him up. Can you add him up to find the unbalance? Quick, quick, quick. Where's my calculator? Where's my friends? Do I have friends? How much? All of them. Where's your calculator?
I'm trying to do it in my head.
Okay. How much?
The average?
Yeah, divide by 3.
Yeah, 481.6.
481.82. 482. So the average of all these together is 482. Okay. 482? Yeah. Okay, now how far is 480? Which one is the farthest away from 482? Is it 80, 90 or 70? 70. So you take 482 minus 470 divided by 482. Can somebody do this math and tell me what the percentage of the unbalance? The percentage of the unbalance?
0.2%.
0.2 or 2%?
No, 2.5%.
2.5%. Okay, now where are we here? We're almost at 3. What's going to happen to my derating my motor? 88% derating. Do you see what happened to the voltage? Do you guys understand what an unbalance in the voltage is? So you want your voltage to be balanced. Within 3%.
So within 3%, so 2.5 is fine.
2.5, within 3% balance is good. Yep. But unbalanced system, voltage-wise, is bad news for you. How you get unbalanced system? If your feeders are, or certain feeders phase is overloaded and the others underloaded. That's why balancing your phase on the three-phase load is essential. That's why it's a fool to put a single-phase panel in a system that you have a three-phase system, like we talked before. Okay, so that's a couple of calculations, guys.
So does the panel self-balance the system?
Yes, if you have a three-phase panel, it will force you to use phase, if you have circuit phase A, phase B, phase C. Phase A, B, C, A, B, C. You have to. Even if you don't want to, you're pulling circuits, right? A, B, C, A, B, C, and go all the way. So by default, you are balancing them. Unless you're going to start A, skip 2 circuit breakers, and go again. Who would circuit this way? Does that make sense? Overcam protection device. Overcam protection device, guys, have a couple of multipliers. Load amp approximate and second fuse blow. Look at this one. If you have a 5 amp fuse and it has dual element time delay fuse, it will take more than 300 seconds to trip. If it's 4 amp ordinary fuse, it will take also more than 300. 8 amp ordinary fuse will never blow. So this is just to give you an idea, guys, how fast the fuses can trip to protect you from overload. So we don't want to spend too much time on that. This is marked service factor and find using fuses to protect you as an overload. Using fuses as an overload. One more time, dual element fuse as an overload. So if your motor has 1.11 full load amp, you need a fuse of 1 1/4 to protect your motor. So use this as a guide, guys. Typically, all the motors that we use have an independent, separate overload protection. This is if you want to use the fuse as a short circuit and an overload at the same time. Typically not commonly used in a bigger projects. Okay, so the same thing. This is if the service factor is 15. A couple of tables. This is my favorite, if you guys don't mind me saying that. These are the NEMA type circuit design motors. You are always in design B, almost design B. And it's used, design B is used for fans, blowers, and a bunch of other things. If you go to design and it has low starting current, lock total current torque is high. If you go to D, low start current and very high lock total torque. So long story short, guys, they size the motors to be able to handle different type of loads. You know, the motor that used to crush rocks are different than the motor that you use to run a fan. Do you understand that? Do you need, the whole idea is, do you need torque? If you need more torque, you have to have a special type of motor. The motor that you use to hold a process, just hold it tight. That's torque motors. They design them just not to rotate, just to torque. So they have different type of motors that design. You guys, almost always, you are right in here. Us in the construction, almost always right in design B motors. Okay, this is just the appliances in the motor. Okay, so that's basically what I wanted to emphasize on this. Any comments, any questions? Any calculation, guys, will be done in a separate class. Any calculation will be done in a separate class. All the calculation we'll do, we've done a lot of them, but in next project, we're going to be doing a lot of calculation for motors too. Any comments, any questions? Yes, sir.
Can we just go back to that slide where you were writing in the 3 phases on that motor? About 3 or 4 well,
Is
not
it
quite there? No. Where you wrote in 3 different phases for the motor, and we were kind of calculating it.
Oh yeah, the balance.
Yeah. For each.
Yeah, the unbalance in the system. Okay, where did it go?
Right there. Go back one.
Yes, right here.
Because you just wrote in 3 values for the phases, and each one is D-rate motor to 98, 95, 88%, but you kind of wrote in like 485 and then four, like, does it matter which order the phases are in? Like, how do you know? Because it's saying to derate the motor to each 98, 95, 88.
Yeah, you derate them means you, if you know your system is unbalanced, then you, if by 1%, then if this motor is rated for 15 horsepower, make sure you don't put more than 98% load on it. That's what this is.
Because you wrote,
The voltages I
485
did,
and then yeah.
these are measurement voltage. You go there and you go phase A to phase B, got one reading, phase A to phase C, one reading, and phase C to phase B, another reading.
Okay.
Does that make sense? That's field readings.
And does it matter which order you put them in? 'Cause
No.
You're comparing that.
Doesn't matter.
C phase to 88.
It really doesn't matter.
Okay.
You're looking at the average and you're looking at the furthest away from the average. That's the unbalance. You average them and then you find the furthest away from the average. Absolutely. So that's any comments, guys? Good one. Any comments, any questions about that? I want to go back into, okay. I can't emphasize, guys, I know you're not engineers, but I can't emphasize the single phasing on motors. It's so important. The overload, size overload based on what I told you is very important because, especially in three-phase motor, because of single phasing. Any comments, any questions? Okay, it's Friday. I don't want to start another lecture for the day, guys. We're on track. So what I'm going to do, I'm hoping today, guys, you will submit your Revit power layout. Am I right to say that? Cool. Shall we do that? The A students, the B and the C will submit today. Everybody else will have until next year. Okay? Thank you.